Okay. Why do we need, just those new measures now of variation? I don't know if you guys heard of standard deviation before, but that's what you're going to be learning. You're going to be learning about standard deviation. You see, we have 3 classes here. Just look at the 3 classes: C1, C2, and C3. They're different data values. You can see the data values are different. But if you find the mean for each data set, it's 75, 75, 75. You find the median, it's also 75, 75, 75. If I tell you, is there a difference, just between the 2 data sets, you're going to tell me, well, they have the same mean, the same median. I don't know how to judge, just on the difference between the 3 amongst the 3 data sets. So is there a tool that we can use to tell whether, just there is a difference between C1 and C2, C3, other than using the mean and the median? We use the mean, we use the median, and they ended up being the same. And actually, I start this section, guys, with my students in the classroom with the following scenario and tell you why it is important to learn section 2.4, this new section. This is what I tell my student. I tell my students, you want to go to the bank, and there are 2 branches of the same bank, and they are both located at the same distance from your home. Let's say you live 3 miles away from bank 1, and you live 3 miles again away from the other branch. They're 2 different directions. So which bank would you go? Which bank would you go to do your transaction? And you have to make, an intelligent decision, just of which bank, just you should go there. Then the students will tell me the one, that they give, just better, good service. I tell them both of them, just offer good service. Then they said probably the one, just where we don't have to wait, just too much online. I said, yeah, that does make sense. If they offer both branches the same service, I would go to the one where I don't have to wait too much time. So we send 2 students to branch 1 and branch 2 and ask them to take records, just of how much, people are waiting online. So our students will go to branch 1 and record the wait time of people waiting, just to be served there. So they bring data to the classroom. Let's say they said 1 person waited 7 minutes, 1 person waited 4 minutes, 1 person waited 6 minutes, etc. We find the mean wait time for both branches, and it turned out to be 8 minutes in both branches. So it's the same average wait time, mean wait time. Then another students will say, well, Mr. Bazzi, we learned about the median. Why don't you find the median? And the one that has a lower median will go to it. I said, that makes sense. So we do the median, and it turns out to be 8 minutes and 8 minutes. Well, that's still going to be tough for us to decide which branch we're going to go to, because they all offer the same mean and median wait time. Then a student will say, well, we learned about the mode. Why don't we find the mode? Although the mode is not a very effective tool, but we'll do it. And then it turns out to be 8 and 8 minutes. And I still ask you to make a decision. Which branch should you go to, branch 1 or branch 2? Well, based on what you learned in section 2.3, guys, about the averages, the mean, median, mode, you cannot make a decision because you get the same results in both branches. So there must be some other numbers that you can learn about, and that will help us make a decision. And those other numbers are called the measures of variation. The first one, guys, is called the range. And I don't know if you heard the range. The range is the maximum value minus the minimum value. So we go to branch 1. We have data from branch 1. The students collected data from branch 1. We will find the range from branch 1. So we'll ask the students, what was the lowest value and what was the largest value? So the range from branch 1, the students will tell us that the largest value was 13 minutes and the lowest value was 6 minutes. So the range will be 7 minutes. Then we go to student 2 who went to branch 2 and got the data from there. I tell him, can you help us find the range, just of the in the second branch? Then the students will say, well, the most that a person waited there was 12 minutes minus 7 minutes, the lowest value, and that was 5. So since branch 2, guys, has a lower range than the branch 1, you can make a decision to go to branch 2 rather than branch 1. So the range is the difference between the one who waited the least and the one who waited the most. I would rather the gap, guys, for me to be 5 minutes between the one who waits the least and one who waits the most rather than 7 minutes. However, the big disadvantage of using the range does not account for all the data that you collected. It only uses the lowest and the largest and ignores the rest of the data, and that's not good. Here, you only use the lowest value and the largest value. So if a student went to the bank and recorded the wait time for 50 students, and the students came back, we only used 2 of the values that the students brought back out of the 50, and we ignored the 48 values. That's the disadvantage of using the range. So there must be some tool, guys, where we can account for every single value that we collected. It's called the standard deviation. The standard deviation, it's a measure, will tell us how consistent the values are with the mean, how close the values are with the mean. So you're gonna learn how to find the standard deviation. I'm gonna do this, guys, by hand the first time, but then I'm gonna show you how to use the calculator, and you can use the calculator from now on when calculating the standard deviation. So there are 3 measures of variation. One is called the range, which I explained to you. The other one is called the standard deviation, which I'm going to explain in a minute. And the third one, guys, is called the variance, which is the square of the standard deviation. So if you have the standard deviation, let's say 5, you square it, 25, that will be called the variance. So 3 common measures of variability are the range, variance, and standard deviation. The range of a data set is equal to the largest measurement minus the smallest measurement. So calculate the range of class 1 scores. So let's do that. It's you can see the largest value is 100 and the smallest is 50. So that will be 100 minus 50, which is 50. If I ask you to calculate the range of class C2, it will be again 100 minus a 50, which is 50. But if I ask you to calculate the range of class C3, will be 80 minus 70, which is 10. Here's a quick question for you guys. Which of the 3 data sets, the value are closer together? Which one do you think? Is it C1, C2, or C3?
3.
3. And the reason why, because the range is small. The range is only 10, guys. The other one is 50. There is a big gap. So when the range is small, that means the data values are very close together. And you can see 70, 73, 74, all in the 70s. But look at C1, 50, 60, 70, 80, 90. Look at C2. We have 50s, we have 70s, we have 100. Here's another question for you guys before I get to the standard deviation. Which of the classes or the data sets, the data is very widely spread out? Most widely spread out. Is it C1, C2, or C3?
C1.
C1, I agree. And the least is spread out, guys, you agree with me, it's C3, and then C2 comes in the middle. The standard deviation, guys, is the measure of how much the data are spread out from the mean. And I can tell you guys, when you learn later how to find the standard deviation, I can tell you from now, for C1, we're going to have the largest standard deviation because there's not consistency. In C3, it's going to be the lowest standard deviation, and C2, it's going to be in the middle between C1 and C3. So we're going to learn now how to compute the standard deviation of the data set. I'm going to do it by hand first, guys, and then I'm going to show you how to use the calculator. And you can use the calculator from now on after I demo the standard deviation. I usually show students how to do the standard deviation with a small data set. So I'm going to come up with a data set. That's 20. Okay. So we have 5 values, guys. 10, 3, 7, 4, 1. I'm going to find the standard deviation of this data set. I'm going to show you the process and how to find the standard deviation of this data set. This is a sample, guys, that I came up with, and we're going to learn how to find the standard deviation. It's good to know how the formula works, guys, and then you can later use the calculator. The formula is already built in the calculator. It will tell us what the standard deviation is right away. Once you input the values into the calculator, you will see what the standard deviation is. First of all, guys, I would like you to help me find the mean, which is X bar of this data. I made it so simple, so it will be easy to find the mean. 10 plus 3, 13, plus 7, 20, plus 4, 24, plus 1, 25, divided by 5 will be 5. So find the mean and put it under each value. Okay, here I'm going to ask a question. How far does the data value 10 deviate from the mean? How far apart is 10 from the mean? Can someone answer this question? How far is 10 away from 5?
5.
5. It's 5 above. Plus 5. Exactly. How far is 3 from 5?
2.
2, but it's 2 below. You agree? Because it's below 5. So it's a
Yeah.
minus. And 7 is 2 above. And 4 is 1 below. And 1 is 4 below 5. Okay. Next step in finding the standard deviation. We square each deviation. So can you guys tell me what would be the square of 5? 5 times 5, 25. If you square -2, the square get rid of the negative sign, guys, so that will be a 4. If you square a 2, it's a 4. If you square a 1, it's a 1. If you square a -4, it's a 16. Okay, we're almost done to find the standard deviation. The standard deviation will tell you if it is a large standard deviation, that means there is too much variation in the data set. If the standard deviation is small, there is very little variation in the data set. That means the value are always gathering around the mean if it is a small standard deviation. Add the deviations. If we add them, we get 25 plus 4 plus 4 plus 1 plus 16. Which is what, guys? 29, 33, 34, 44, 50. Okay. Divide 50 by the number of observations minus 1. How many observations do we have, guys, here? 1, 2, 3, 4, 5. 5 minus 1 will be 4. When we work with the sample, we divide by the number of observations minus 1. When we work with the population, we divide just by the number of observation. So it's 50 divided by 4, which is 12.5. And here's what the standard deviation is, guys. It's going to be a larger standard deviation because you notice that the values deviated from the mean by so much. Look at the deviations from the mean. The standard deviation, guys, since we square the values here and we were not supposed to square any values, we have to undo the action. So just take the square root of 12.5. And let me show you how to find the square root of 12.5 on the calculator. So you just bring the calculator, turn it on, and just put, you go second, and this is a square root, and put to a 12.5 there, enter, and it is 3.5 to one decimal place. Any questions here?
Yes, please.
Yes, go ahead.
I got a bit lost. Where you did 50 divided by 4, where did you get the 4 from?
That's a good question. Okay, count with me here. How many values do we have? 1, 2, 3, 4, 5. If it is a sample, we'll take 1 away. And this is a sample, as I said. So 5 minus 1 is 4, and this is where the 4 came from.
Oh, okay, thank you.
However, later, you don't have to worry about it. You're just I'm gonna show you how to use the calculator to get the answer right away. So, but you need to know where the formula came from. This is the formula, guys. And this is the standard deviation, 3.5. Now, my question to you guys, is a 3.5 a large standard deviation when you look at the data values? Well, yeah, 3.5, if you look at those values, it is large because these values are small. Look, the standard deviation is larger than one of the values, which is 3. It's larger than 1. It's almost equal to 4. So that's a large standard deviation. That means there is so much deviation, you know, just in this data set. So 10, 3, 7, 4, 1 produced a very large standard deviation, which was a 3.5. Now, if I give you this data set, guys, and ask you to find the standard deviation. What do you think? Do you guys agree with me if I find the average? What's the average of this data set? Let's find the average. 4 plus 3.8, that's 7.8, 11.9, 15.9, 18.9, 19.65. And if I divide this to find the mean, divided by 5, 35.5. So it's going to be 3.93. Would you guys agree with me that those values are very close to 3.93? That means the standard deviation has to be low here because they are consistent. When the values are close to the mean, that means the standard deviation is low because it's a measure of consistency. The standard deviation will be low. I can assure you guys, 1,000,000% that's not going to be 3.5. It's going to be a very small number, which I'm going to demonstrate to you how to find the standard deviation using the calculator. So when the values are close to the mean, the standard deviation is low. When the values are too much spread out from the mean, the standard deviation is large. And let's show you how to use the calculator now to compute the standard deviation. You ready for that? So first of all, you go to Stat, Edit. I'm going to put the data in L1. Here's how we clear the values in L1, guys. Just move the arrow up and hit clear right here, and then enter. Okay. Let me start with the values that I put at the very beginning. So I have 10, 3, 7, 4, 1. Okay. And I'm ready to show you the standard deviation. Stat, calc. Same thing as we did for the mean median, guys. Exactly the same thing I'm gonna do. Scroll down, hit calculate. The mean is 5, as you can see, guys. That was the mean. Let me show you what the standard deviation. Standard deviation was 3.5, and let me show it to you right here. Okay. There are two standard deviations here, guys. One is called S. If you have a sample, then you look for S as your answer for the standard deviation. It's a 3.5, guys. That's what I came up with by hand. And if he tells you your data set is the population, then your standard deviation will be sigma, which is 3.16. But since I told you what we were given was a sample, then your standard deviation was 3.5. That is the standard deviation. So now we learned how to find the mean. This is the standard deviation right here on the calculator. And if you guys scroll down, you're going to see the median as well, which is 4 right there. I would like to go to the second data set where I told you, I can tell you that the standard deviation is going to be very low with the other values that input. So I'm going to clear them and put, guys, the new values, the 4, the 3.8, the 4.1, the 4, the 3.75. Any guesses, guys? What do you think the standard deviation is going to be? It's going to be a small number. Can someone guess what that number would be? You cannot tell me exactly, but you can make an intelligent guess. Any guesses? Put them in the chat. Okay, let's see. No guesses? It's going to be very low, guys. Watch. Hit calculate. You see the standard deviation, guys, is 0.148, 0.15. And the mean was 3.93, which I did the mean. Because the values are very close to the mean, the standard deviation is going to be very low. That is considered a low standard deviation, and you can make a conclusion that your values are very consistent with the mean. That is based on the standard deviation. When do you use sigma as your answer? If he says what you have before you is the population data. Most of the time, guys, it's going to be S because we use samples. Most of the time, we don't use the entire population. So that is the standard deviation. Let me, and please participate in that. Let me ask you this question, guys. If I come to you next time after you take the first test and I tell you the average score of the class was 78 and the standard deviation was 0, what conclusion will you make about how students did in the class? What's the conclusion?
They all did the same.
Exactly, very good. 100%. They all did the same because when the standard deviation is 0, that means there was perfect consistency with the mean. That means everybody scored 78. Okay, that's good. Let's change it now and see the standard deviation was 20. Can you guys say something about what happens on the test? If the average score of the class was 78, but there was a large standard deviation, guys, at 20, what would that say to you? What is it that I'm trying to tell you? Don't be shy of participating. I'll correct you if you make a mistake. A large standard deviation, guys, means that the scores were very spread out. Very spread out, guys, that's scary in a statistics class, meaning that there were students who did very well, but there were students who did very poorly. That's how the scores will spread out. If everybody did very well, that means the scores all will be high and they're not spread out. They are all on the high side. A standard deviation of 20, guys, means there were some students who did very, very well, and there were some students who did very poorly. And that's a concern. When I see, guys, a big standard deviation, you know, when I compute the scores, I become very concerned here. And why the average turned out still to be a good average? Because a very high score with a low score, if you add them up and average them up, it will turn out to be a good score still, you know, just not a bad score. So that is what a standard deviation was 20 means. Now let's change this one and make it 3.5. If I say the standard deviation, guys, was 3.5, that means very much most students score close to 78, give or take, plus or minus. So the average of the class is passing. Most students did very close, you know, just to this passing average. Some students score a little bit higher, more than 78. Some students score a little bit less, but it's not a disaster with a standard deviation of 20, meaning that there were many students failed the test. So this is how you can use the standard deviation, guys, to make a conclusion about a data set. I'm going to give you another scenario, which is an example that I use a lot in my classroom so students can comprehend the concept of standard deviation. Let's say you are a basketball coach, you know, and you want to hire a new player. So you interview two players, player one and player two. You look at their past scoring records, and player one, you have the following data from player one. On one game, he was able to score 19 points. On another, it was 20, and then 18, and then 24, and then 15. So you got the following data. In player two, you got the following data from player two. One game, he scored 39 points. Then another game, he scored 7 points. Then 18, then 29, then 10, then 15. That's the data that you have from player two. As a coach, you are interested, you know, just you want consistency. You want to bring someone to the team and that can guarantee a certain fixed number of points, you know, just each game, that this person will be able, you know, just to get those points. Which player would you hire? Would you hire player one, or would you hire player two? How do you make a decision? If my consistency is my concern, so which player, guys, would you? And you don't even need to crunch the math, because I made the data, you know, just very clear. Then you can see what the outcomes are going to be. So which player would get the job, guys? Do you think player one or player two? Player one. And why is that? That I agree. Do you guys agree with me that player one seems to be more consistent than player two? It seems like on average, he will score about 18, 19 on each game. That's so then the coach, would think that this player, just is gonna guarantee about 20 points on each game. But look, player two in a good day, probably 39 points, but on a bad day, it could go down to 7 points. And would you guys agree with me that if we find that standard deviation, that the standard deviation of player one is going to be lower than standard deviation of player two? So if I give you this question on a test and I'll ask you, just which player is more consistent, you will tell me player one, but you will find the standard deviation and prove that he is consistent. And you're going to find out, guys, that the standard deviation of player one is much less than the standard deviation of player two. And I'm going to prove this to you right now. So we're going to put the data, edit. So I'm going to put the data here, 19, 20. If you have your calculator, you can work with me, 18, 24, 15. And look what we're going to do, guys. We're going to go to L2 and put the data for second player. 39, 7, 18, 29, 10, 15. Any guesses, guys, for player one? What do you think the standard deviation is going to be? Look at the values. And you guys, you can see my calculator, right, that I have on the screen, correct? Just please confirm, because I don't want to make sure that I'm not doing the work for me.
Yes, we can see it.
Great. So stat, calc. And guys, this is what's going to make this course an easy one, not challenging one, using technology. You're not going to sit down and work tedious calculations by hand. This is all not required. And just have a good grasp, just of the technology, and you should be fine. So one variable statistic, L1, that's the first player, and just hit calculate. And it's S because it's a sample, guys. So it's a 3.27. I'm going to write it down. Okay, let's see the player two. I'm very positive, guys. Player two is going to be a lot larger, more than 3.27. So let's go to that. Stat. You can see that's the feature of chapter 2. Stat, calc, one variable statistic. Okay, there is one thing I need to change here, guys. Otherwise, I'm going to get the same results of player one. What is it that I need to change? If I do nothing, I will just get the same answer. Yeah, list has to go to L2. Exactly. Look, how do you change the list to L2? Press the second key and type number 2. And this is L2. So second, always when you want to change the list name, just press the second key and type the number that you want. And I'm done. Just let's hit calculate. And look at the standard deviation, 12.16, guys. If the coach cares about consistency, he must hire player 1. If he likes to take his chance, you can hire player 2. He might score too many points and he might end up scoring very low number of points. So, but consistency, guys, the name of consistency is player 1. I hope that will give you a good overview of what the standard deviation is about. All right, so that's okay. There is a formula for the standard deviation. As I told you, you're going to see the formula, but you don't have to worry about it because it's built on the calculator. And let me just go through this formula with you, because you're gonna see it, just probably somewhere in the book. So here's the formula for S. This is called the sample standard deviation. And how did the sample standard deviation? You remember, guys, how I did it. I found the mean. I subtracted the mean from each value. I squared the difference. And then we added up the values. And then we divided by the number of values -1. And then we took the square root. That's exactly what I did. Now, what is S2? S2 is called the variance. It's the square of the standard deviation. It's the same formula like here, but without the square root. And this is called the sample variance. All right. This is the sample variance. If he asks you to find the variance, guys, you just use the calculator. You find S, and then you take this value and square it, multiply by itself, and then you get what we call the variance. Now, for population standard deviation, here's the formula, guys. It's called sigma, which is population standard deviation. I'm going to write it down. It's the same thing as above, but without n-1, it's n. The mean, when we do population, we use population, it's called the mu. So sigma squared divided by n. That's the formula. Again, you're not going to be required to do it by hand at all. And the population variance is called sigma squared. Which is the same formula, but without the square root, guys. Now, if you ask me what's the difference between this and that, same thing. That's a sample mean. It's just a label. This is the population mean. You just do the same work to find the mean. He says, calculate S square and S for the class 1 scores. I'm just going to do it, guys, with you and show you how to do it one more time. So these are the class 1. Let's put them in the calculator. Stat. And you guys, if you like, I'm going to show you how to use L3 here. Let's put him in L3. 50, 60, 70, 80, 90, 100. Okay. Go to stat. Very easy if you know what you're doing. Calc. One variable statistic, and change this to L3, number 3, and that's it. Hit calculate. I think it's going to be a larger standard deviation, guys. S is 18.708. That's the standard deviation. He wants the variance, so just square it. So let me write it down. Will be 18.7 if to one decimal place. And the variance, guys, which is S squared, will be 18.7 squared. And we just use a calculator to find it. I could do it here. 18.7 times 18.7. I'm trying to go very slow, guys, with you because I want you to try to grasp the material well. And that's the variance, 349.69. We usually use the standard deviation more than the variance, because the standard deviation has the same unit as the data values. So like if the data values are in dollars, the standard deviation will be in dollars. The problem with the variance, guys, because we square the standard deviation, the unit will be dollar square, which it doesn't make sense. So we use a lot the standard deviation rather than using the variance. Okay. Any questions? All right, let me just grade this out. So I would like to assume, guys, that you know now how to find the mean, median, mode, range, standard deviation, and variance of a data set. And they are all can be found in one shot just using the calculator like I did. Okay. And as I told you guys, the standard deviation has an advantage on over variance because it has the unit as the data set values. I put an example here. The standard deviation of a set of incomes in dollars would be in dollars, where the variance will be in dollars square. And the standard deviation can be used in conjunction with the mean to describe the variability in a single data set. I'll give you another example, guys, on how the FDA, for example, if someone, a consumers, just files a complaints about a packaging company, they complain, let's say, just their cans say it has 12 ounces, but the consumer complains probably it has less. So what would the FDA do in this case? This is what they would do, guys. They will go to this store and collect, just a random sample of those cans. They get a random sample. They weigh each can and they find the standard deviation. Let's say they take 50 cans. They have the weight of each can, they put them on the scale and they get the weight, and then they find the standard deviation. Let's say the standard deviation turned out to be this, guys. Do you think the complaint is valid? Look at the standard deviation. The variation, it's about 0.07 ounces, and the can is supposed to have 12 ounces each. Do you think there is consistency in the weight of the cans based on this standard deviation? It's 0.07. Would you guys agree with me that this is a low number? This is very low. Not even a 0.1 ounce. It's very, very low. When companies, just package, just all fill up, those cans, they're not going to be able to put exactly 12 ounces there. That's impossible. It's going to be a plus or minus. So with a standard deviation that low, guys, the FDA can determine that the consumer's complaint, just has no ground. And they wouldn't do anything. But if the standard deviation is this, 0.67 ounces, almost 1 ounce, guys. There is 1 ounce variation in the can's weight. That's a big deal. Then that's a different story. So you see, a low standard deviation requires, just no action. But a high standard deviation, then probably, just an action should be taken. Now, how do you know which is high and which is low? Well, for 12, a 0.07 is a low number. But a 0.67 compared with 12 is a large number. It's a good fraction of 12. So that's how you decide whether there is something wrong, there is consistency, or there is not consistency in the data set. All right, guys, any questions? Exactly. Have a question about the variance. You square the standard deviation, but standard deviation you leave alone. That is correct. Okay. Very good. Okay. One more thing in section 2.4 before we wrap it up. That's right here. It's the empirical rule. I'm going to explain this rule to you and tell you what that means. Okay, the title here should be Empirical Rule. Okay. That's probably going to take you by surprise to know this, guys. If you collect the data and you try to sketch your data, graph it using a histogram, most of the data sets, guys, that we collect will turn out to look like this. Let me show you. What does this look like? Which type of shape, guys, that we talked about earlier? Symmetric. There is a symmetric. Why? If we collect data about people, I mean, we have so much in common. We have so many characteristics. So most of us, the overwhelming majority of us are going to be here. There are going to be a few of us who are on this extreme, and there are going to be a few of us who are on the other extreme. For example, let me give you an example, guys, of how much students spend on lunch at the college. Most of you guys would go to the cafeteria. Most of you would order very much the same thing. So most of you are going to be here. There are a few students who don't eat there or just go and grab a cup of coffee or anything. They're going to be on this side. And there are some students who would like to go, and very few of them would like to go out and eat at a fine dining or etc. and spend a little bit more money. They're going to be here. But the overwhelming majority, guys, will be there. So most of data sets that we collect and try, just to sketch will turn out, just to look like this one, which is a bell-shaped graph. So instead of doing all those bars, I'm going to resketch this one like that, guys. And this is the mean right here in the center. So this is called the bell-shaped curve, guys, or symmetric graph. Okay. Let's suppose we have a data set and we know that the mean is 50, for example. We found the mean to be 50. And we find the standard deviation to be 10. So sigma is 10, guys. Or S. I can use sigma or S. It doesn't matter. Let me tell you how we scale this number line. As you know that the mean is right in the middle, in the center, that's a 50. And values that move to the right are larger than the mean, and values that move to the left are smaller than the mean. But I'm going to tell you something, guys, that all of the values in the data set should not exceed 80. And I don't know if you guys can tell where the 80 came from. And all the values on the low side should not go any lower than 20. Anyone can guess how did I come up with those two numbers? It's a guessing game now, and I'll tell you how in a second. Any ideas, guys, where the 80 came from? I told you that the mean is 50 and the standard deviation is 10. Where did I come up with those 3 tick marks and got me to 80? Think about it, guys. What do you think? No answers? How many times do you have to add 10 to get 80? If you add it 3 times, you get 80. So look what I did, guys. 50 plus 10 is 60. Added 1 standard deviation, 2 standard deviation, 3 standard deviation. For your information, guys, the values in the data sets do not go usually beyond the 3 standard deviation from the mean. They won't. It's most of the values, almost 100% of the values will be within 3 standard deviation from the mean. You will not find any values that go above a 3 standard deviation from the mean. And the 20, where did I come up with 20? This is what I did, guys. I subtracted a 10, then I subtracted another 10 from 50, and then I subtracted a 10. So 50 minus 10 is 40, and 40 minus 10 is 30, and 30 minus 10 is 20. And you can see most of the values are picked up between 20 and 80. If I have a student, guys, that's taking my test, and these students consistently keep getting, you know, a score which is more than 3 standard deviation above the mean, I'll tell the students, you don't belong to the class. You're too smart for this class. You should not be there. But if a student also is way below 3 standard deviation from the mean, I'll tell the students that you are on the very, very weak side. Probably you should go drop down to a different class. But in any data set, guys, most of the data can be captured within 3 standard deviation of the mean. What do I mean by within? Within means I add 3 standard deviation to the right, and then I subtract the 3 standard deviation from the left. So all my values, guys, should be, almost all of them should be between 20 and 80. That is what we call the bell-shaped curve. This is the mean. This is 1 standard deviation above the mean. This is 2 standard deviation above the mean. And this is a 3 standard deviation above the mean. Here, 1 standard deviation below the mean, 2 standard deviation below the mean, 3 standard deviation below the mean. Now, most of us, guys, are within 1 standard deviation of the mean. Within 1 standard deviation of the mean, guys, is going to be this. 1 above and 1 below. And statisticians find out that this captures 68% of the data. So 68%, guys, of the data is right here. The whole thing is 100%. Now, within 2 standard deviation of the mean, guys, within 2 standard deviation of the mean means between 30 and what? And 70. Because 50 plus 10 plus 10 will give you 70, and 50 minus 10 will give you 30. Here's the percentage, guys, that the statistician found out here from the experiment. This percentage, guys, is 95%. So 95% of us, guys, are within 2 standard deviation of the mean. Now, let me see what happens when we go 1 more standard deviation to the left and 1 more standard deviation to the right. What percent of the data we capture? We capture most of it. There is a tiny bit tail here, here, and there. This is 99.7% of the data, guys. Not 100%, because I said almost 100%. 99.7% of the data is captured between 20 and 80. So there is a 0.3% that, guys, it's not captured. And actually, I gave a name, you know, to those special values earlier when we talked about section 2.3. Does anyone remember the name of those values? Are too far to the right or too far to the left? What did we call them? Remember the house example. Does anyone remember what those values are? These are the ones that we didn't pick them up here. This belong to the 0.3%. But 99.7% of the data is between 20 and 80. There is a 0.3% that we could not capture. These are the outliers. For example, guys, average spending money on lunch, you know, by students is like, let's say, $6-7. And then here is a student who went out and ate sushi and spent $70. This $70, guys, is going to be an outlier. it's not going to be, we're not going to be able to capture this value in this curve. It's going to be way toward, just the right. And this is what an outlier. And that's why we don't put 100% there. Okay. What I told you, what those 3 percentages that I explained to you, the 68, the 95, and the 99.7% are called the empirical rule. So we say 68% of the observation fall within 1 standard deviation of the mean. 95% of the observations fall within 2 standard deviation of the mean, and 99.7% of the observations fall within 3 standard deviation of the mean. And I'm going to show you an example and how to work, just with those 3 percentages. I would like you to try to memorize those 3 percentages, guys. The first percentage is 1 standard deviation within. Within, guys, means above and below. It could be above and it could be below. 95% of the observation fall within 2 standard deviation of the mean, 2 above and 2 standard deviation below. Okay, so let's look at this example. This is what we call the empirical rule. But the empirical rule requires that the data must be bell-shaped. If the data is not bell-shaped, the empirical rule does not work. Only in bell-shaped data, symmetric. 500 juniors at Central High School took the ACT last year. The scores were distributed normally. Normally means bell-shaped, for your information. With the mean of 22 and a standard deviation of 33. Label the mean and the 3 standard deviation of the mean. So here's how we're going to label it. Let's do it together, guys. So this is a 22. Can a student tell me what the next number is going to be? $25. Yes, correct. In the chat, the students added 3, 25. And what's the next one, guys? Please help me out.
28.
28. I agree. And what's the next one?
31.
Exactly. The tail looks like it's touching, but actually I did this, so it usually doesn't touch. There is like, just it goes along the horizontal line, but it never touches, just to pick up those 0.3%. And can you guys tell me what the values from the left-hand side are going to be?
19.
Mm-hmm.
And 16.
16.
And what?
30.
30. You answered the first question, guys. And this is the mean right here. Look, the mean is right at the center. That's the mean. Okay. Let me show you what kind of questions you should expect here. You did this. It's all based on you memorizing the 68, 95, 99.7% fact. Okay. What percentage of the scores are between 16 and 28? Let me just gray it out, guys, so you can see what I'm talking about. It's either you know this answer or you don't know it, guys, because if you know the rule. Okay. What's the percentage? It's going to be either 68, 95, or 99.7%. Which one is it going to be, guys? Do you guys agree with me that 16 is 2 standard deviation below and 28 is 2 standard deviation above? When it is 2 standard deviation above and below, the percentage will be what, guys? 95%. So the answer will be 95%. Okay. Let's see. What percentage of the scores are between 19 and 22, guys? This. Let's see if a student can answer this.
68.
68 for above and below the mean. This is only for the one below the mean, 1 standard deviation below the mean. So you're getting very close. This is the 68. The 68 is all the red. If I want this part only, what would that be? What do you do with the 68%? Divided by what? By 2. So that's a 34%. And that's a 34%. So that would be 34%, guys. Okay. What percent of the scores is between, I'm going to change this, 13 and 31? $13 and 31. We should know that by heart, guys. This is 3 standard deviation above and 3 standard deviation below. The percentage is what?
99.7.
99.7%. Okay. So we know this from 13. Pay attention to this, guys. There's one more question. All the way to 31 is 99.7. Look what he wants now. What percent of the score is less than 13? Right here. Who can figure this out? Less than 13. Remember, the whole area is 100% under the curve. We know from 13 to 31 is 99.7%. What would be left for less than 13 here, guys? A tiny bit. You can barely see it. And there is a tiny bit on this side as well. Any ideas?
0.3.
0.3. Very good. You're getting close. It's a 0.3. And you guys, do you know where she came up with the 0.3? Because she subtracted 100% minus 99.7.3. But remember, the 0.3 is split up between the right tail and the left tail. So what do you think I'm going to do with the 0.3 here? Divided by what? By 2. So it will be 0.3% divided by 2. Which is 0.15%. And these are the outliers, guys. Anything above 31, anything below 13 is going to be an outlier. It's beyond 2 standard deviation from the mean. Okay, let's see, guys, if you can figure out the last one. What percentage of scores is greater than 25? I want this. All the way, the black one. To give you a hint, guys, what is this one? What did we say this one was? You guys agree? We say it's what? 34%. And remember, the mean is right in the middle, so it's at 50%. The mean splits up the curve into 2 pieces, 50-50. So if this is 34%, how much is left for the black shaded area? Remember, that's the 50% from here and up. That's 34. What's left for the black shaded area? What do we need to add to 50%, 34% to make it 50%? Yes? It is 16%, because 16 plus 34 will give you 50%. One time I asked students a very simple question. What percent of the values are bigger than 22? You just say 50%. If I say what percent of the values are smaller than 22, you just say 50%, because 22 is the median, is the mean, is right at the 50% location. You're gonna have questions in the homework. He will give you the mean, he'll give you standard deviation, and he will ask you a question. What percent of the values are between 19 and 25? You look at 19 and 25, and you notice that they are the result of adding one standard deviation to the mean and subtracting one standard deviation, just answer 68%. And something like that. So this is what we call, guys, the empirical rule. And it's called the 68, 95, 99.7% rule. The 68 belongs to one standard deviation. The 95 is 2 standard deviation. And the 99.7% is 3 standard deviation. Now, how do you use this rule, guys? And as far as standard deviation, if I tell a student that your score on the first test was 2 standard deviation above the mean, should the student be happy with this news? I think the student should be very happy, because he's almost right here, 2 standard deviation above the mean. He's one of the top 95%. But if I tell the students that your score on the test was 2 standard deviation below the mean, the students will be here. That's bad. That's bad news. First of all, it's you are below the mean, and not only you are below the mean, you're way below the mean. You're 2 standard deviation away from the mean, from the negative side. But if I tell students you are 1 standard deviation above the mean, that's good news too. You're above average and you're 1 standard deviation above. If I tell the students you're half a standard deviation below the mean, that's not good news, but it's not very bad. You are below the mean, but not too far below the mean. I mean, you are close to the mean. So you need to do a little bit more work, just to get to the mean. And if I tell you you are 0 standard deviation from the mean, that means your score is exactly the mean. When the standard deviation is 0, guys, the score is exactly the mean. Standard deviation can't be negative. It's always positive numbers. Okay, I'm gonna do one more. And I wanted to do an activity, but I just looked at the activity. It has some questions from section 2.5. So I'm gonna postpone that until later. We'll do it later. Make sure, guys, let me just pause for a second. All right, so let's do the curve first. Okay, what did he say the mean was? He says the mean was 490. You put the 490 right here, guys. And then you tick 3 tick marks to the end and 3 tick marks from the other side. And the standard deviation, he says it was 100. So that's 590, 690, 790. The highest score is 800, but it doesn't seem like we'll pick it up with this. 390, 290, 190. And I don't think anyone can score less than 200 on the SAT. So that's the SAT. Okay. Help me out, guys, with this one. Let's answer the first question. So what percent of the scores are between 390 and 590? That should be an easy question, guys, if you know the rule. 390 and 590. Who's going to give me the answer? You can put it in the chat if you like. 68%. 68%, that's it. It's 1 standard deviation, so 68%. Okay, one student scored 795 on this test. How did the students do compared to the rest of the scores? 795, guys. Let me show you where the 795. Right here. What can you say about this student, guys? Should be able to say something. Do you guys agree with me that he's more than 3 standard deviations above the mean? Because 790 will take me to 3 standard deviation. So I could say this student's score probably has the highest score of all scores, because he's way beyond the 3 standard deviation. I would say that the students probably had the highest score, which is a good thing. Okay. C. A rather exclusive university only admits students who were among the highest 16% of the scores on the test. So if they say they only accept the top 16%, what score should you get, guys, in order to be admitted to this school? So let's see where the 16% is going to be. Do you guys agree with me that this is a 34%? This is a 34%. If this is a 34%, guys, how much is left for this area? Remember, that's 50%. That splits it up in 50. So can you give me the percentage of the remaining area? I'm going to shade it. Let me shade it in red. So what is the area here, guys? You should know that by heart now. If this is 34%, how much is left for this area? 16%. Because 34 plus 16, guys, is 50%. So these are the top 16%, guys. These are the top students right there on this line, right here. It can go all the way up to whatever score, 800. But what's the lowest score that a student must score in order to be in the top 16%? Can you see the beginning score, guys? What should the score be? You see, it begins at 590. So any students who score 590 and higher will be admitted to this school. 590 or higher. These are the top 16%. Last question, guys. The senior class at POP has 450 students and offers a 500 scholarship to everyone that gets above 690 on the test. What percent of the students will get the scholarship? Above 690. So all I'm asking you guys, give me the percentage here, above 690. I want this percentage. Who can tell us what it's a small percentage, guys. What do you think this percentage is? And any students who give me the correct answer right now will receive an extra point on the chapter 2 assignment. So just
16.
Well, 16 is for from 590 all the way to the end. I want it from 690 all the way to the end. So what I said, guys, so that will show up in the recording. From 290 to 690 is 95%. What remains here is the 5%, but I want only on one tail from 69 and up, which is 5% divided by 2, which is 2.5%. And that's the answer, 2.5%. That is the empirical rule. It's called the empirical rule in section 2.4. So with this one, guys, we have done sections 1, 2, 3, and 4. We have one more section that I'm going to do next time on Monday. It's an easier section. It's about measures of position, first quartile, second quartile, percentile, etc. We will learn that and we'll wrap up chapter 2 next time we meet.